Hello friends, today we are going to study Otto cycle. See, this is very important cycle for our GATE examination, and alternatively it is seen that a 2 marks question generally comes from a Otto cycle. Now see, Otto cycle is a 4 stroke, 6 event cycle, and generally it is used in SI engines. SI engines means spark ignition engine. Fine. Now, what do we mean by SI engine, spark ignition engine? That means the combustion in the combustion chamber is taking place with the help of a spark. Fine. And generally the fuel used is gasoline, which we refer it as petrol. And see, the 6 events that take place in an Otto cycle are: the first one, suction stroke; the second one is that compression stroke; the third one is combustion. Now see, this event is not counted as stroke because this is an instantaneous process. Now fourth is expansion stroke. Now fifth is blowby, or we can simply say it as heat rejection. And again, this is not counted as stroke because again this is a instantaneous process. Now the sixth event is that of exhaust stroke. Now see, this suction stroke, compression stroke, expansion stroke and exhaust stroke, these make 4 stroke cycle, and combustion and blowby are instantaneous events in Otto cycle. Fine. See, this is a piston cylinder arrangement, and this is the piston, and this is the crank, and crank is connected by piston with the help of connecting rod. Fine. This is engine cylinder, and the region enclosed between the walls of engine cylinder and this piston, this region, it is simply known as combustion chamber. Why it is known as combustion chamber? Because here combustion of fuel takes place. Now see, this is our inlet valve and this is our exhaust valve, and this is the spark plug. This constitutes our piston cylinder arrangement in IC engines. Fine. Now we will study various strokes one by one. Now see here, when this crank is rotating, the piston is getting reciprocated. So rotation of crank is getting converted into reciprocation of piston. Now see, when this crank rotates, this piston will move from upside to downward. So there will be a reciprocating motion between top dead center and between bottom dead center. Fine. Now first of all, come to suction stroke. Now see what is happening. Now see, initially the position of piston is at top dead center. And when this crank is rotating, from A to B, the piston is moving from top dead center to bottom dead center. And when this piston moves from top dead center to bottom dead center, a low pressure region is created in combustion chamber. Again speaking, when the piston moves from top dead center to bottom dead center, a low pressure region is created in combustion chamber, due to which this inlet valve opens. And when this inlet valve opens, a fresh charge comes inside the combustion chamber. Here it is the fresh charge. And fresh charge constitutes of fuel plus air, and this is referred as suction stroke. So suction stroke takes place across 0 to 180 degree of crank rotation. See this angle, the crank is moving from position A to B, so there is 180 degree of crank rotation, and initially the piston is at top dead center and the piston is moving from top dead center to bottom dead center. So this is the first stroke of Otto cycle, or the first event of Otto cycle. So here we see that inlet valve opens, and see this exhaust valve is closed. And the piston moves from top dead center to bottom dead center, and during its movement from top dead center to bottom dead center, low pressure area is created in combustion chamber, due to which combustion chamber is filled with fresh charge. Now see, here now when the piston is at bottom dead center, this combustion chamber, this area gets filled with fresh charge. Now the second stroke is that of compression stroke. Now see what happens in compression stroke. Now see, after suction stroke, what is happening? The piston is at bottom dead center and the position of crank is that of B. Now crank is rotating from B to A. And that's why the piston is moving from bottom dead center to top dead center. So again it is covering 180 degree to 360 degree of crank rotation. So compression stroke comprises of 180 to 360 degree of crank rotation, and in this stroke piston moves from bottom dead center to top dead center. Now see, in this case compression stroke, both inlet valve and exhaust valve are closed. So when the piston is moving from bottom dead center to top dead center, this fresh charge gets compressed. So what is happening in compression? Fresh charge gets compressed. Fine. Now the third event is that of combustion. Now see, after completion of this compression stroke, what is happening? The position of piston is at top dead center, and this is compressed fresh charge. Now here is the spark plug. When the position of piston is at top dead center, we give a spark to compressed fresh charge, due to which combustion takes place. So the third event taking place is that of combustion. So it is a instantaneous process of heat addition. Why it is called instantaneous process? Because it takes place when the piston is at top dead center, or when the crank position is at 360 degree after completion of compression stroke. Fine. Now the fourth event is that of expansion stroke. Now see, after compression stroke, the position of crank is that at point A, and this is point B. And in next stroke, expansion stroke, the crank moves from position A to position B, and this corresponds to 360 to 540 degree of crank rotation. So expansion stroke corresponds to 360 to 540 degree of crank rotation. Fine. Now see what is happening. Here there is burned gases. Now see, after combustion there is burned gases in combustion chamber, and these burned gases are at very high pressure, and these high pressure burned gases forces piston from top dead center to bottom dead center. So what is happening? Piston is moving from top dead center to bottom dead center, and here again see, both inlet valve and exhaust valve are closed. So inlet valve and exhaust valve are closed. Fine. This is known as expansion stroke. Now see the fifth event. The fifth event is blowby. Now see, Again, this blow by is not a stroke, it is an instantaneous process. And blow by occurs after completion of expansion stroke. That means when the position of piston is at bottom dead center or the crank angle is at 540 degree. Now see what happens in blow by. Now see, this exhaust valve gets open. See, this is the exhaust valve. Exhaust valve gets opened. Now see, here there were high pressure burnt gases and here it is atmospheric pressure. Now due to this pressure difference, the burnt gases will escape from exhaust valve. So what is happening? Burnt gases escape from exhaust valve, and see, these burnt gases are at very high temperature. So when these burnt gases escape to atmosphere through exhaust valve, we can say it as process of heat rejection. And see, this heat rejection or blow by is an instantaneous process like that of combustion. Fine. Last stroke is that of exhaust. Now see, after completion of this expansion stroke, the position of crank is that at B and the piston is at bottom dead center. Now the crank will rotate from B to A, and this corresponds from 540 to 720 degree of crank rotation. Fine. And in this movement, the piston will move from bottom dead center to top dead center, and in case of exhaust stroke, this exhaust valve is opened. Now see, here the exhaust valve is opened, and when the piston moves from bottom dead center to top dead center, it sweeps away the remaining burned gases from this combustion chamber, so that in next stroke or in next cycle fresh charge can come in this combustion chamber. Again speaking, when the piston moves from bottom dead center to top dead center in exhaust stroke, what is happening? It is sweeping away the burned gases, the remaining burned gases from this exhaust valve, so that in next cycle the fresh charge could come inside the combustion chamber through inlet valve. So these are the 4 strokes of Otto cycle and 6 events of Otto cycle. Now see, again 6 events. Suction stroke, and it can be considered as constant pressure process. The second is compression stroke, and it can be considered as reversible adiabatic compression. The third is combustion, and it is an instantaneous process, therefore it can be considered as constant volume heat addition. The fourth is expansion. And it can be considered as reversible adiabatic expansion. The fifth one is Blowby. And again it is an instantaneous process, so it can be considered as constant volume heat rejection. And the sixth, exhaust. It can be considered as constant pressure process. Now see, suction stroke, compression stroke and exhaust stroke, these three strokes are power consuming strokes. And only power producing stroke is that of expansion stroke. Power producing stroke. Now see, what is happening in expansion? When the burnt gases expand, the piston move, downward movement of piston rotates the crank. And see, during expansion, what is happening? The piston is moving from top dead center to bottom dead center, and the burnt gases at high pressure pushes the piston downwards towards bottom dead center, and due to this motion the crank rotates. The crank rotates, and with crank is attached a shaft, and with shaft is attached our tires. So due to rotation of this crank, the shaft rotates and the tire rotates, and ultimately our automobile moves ahead. Now see, in these strokes, suction stroke, compression stroke and exhaust stroke, the movement of piston takes power or takes energy from the crank. So suction stroke, compression stroke and exhaust stroke are considered as power consuming stroke, whereas the only power producing stroke is expansion stroke.